So when we graph quadratics, we have several different ways we can look at them. This one is in standard form. So that means it's the form ax squared plus bx plus c. When you have something in standard form, you can find the vertex by putting it into vertex form. You can find the zeros by putting it into factored form or solving with the quadratic, and you can find the y-intercept by just looking at it. So if you plug in a 0 for your x, you will find your y-intercept. Why is that? Because here is your x-coordinate, here is your y-coordinate, and if x is 0 right here, then you know what it is on the y-axis. So if I plug in x of 0, I end up with 9. I'll just show that. So f of x would be f of 0 equals 0 squared plus 6 times 0 plus 9. So f of 0 is 9. That's where x is 0 and you've got a 9 for your y. So let's say we go by 2's on here so we can fit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be my y-intercept. So I'll erase that. And we've got our y-intercept. Should we want to get our zeros here, we could do that by putting it in factored form. But before I'll do that, I'll find my axis of symmetry. Remember, that's your x value of your vertex. So my axis of symmetry is x equals negative b over 2a. Well, my b is 6, so it's negative 6 over 2 times 1, or 2. So x equals negative 3. So that means my axis of symmetry is x equals negative 3. So let's erase this so we have room for that. And we'll plot it. And 1, 2, 3. I'll go by the same scale here just because it will not confuse you as you go on. So here's my x equals negative 3. That's my axis of symmetry. That means that's my x value of the vertex. So my vertex is x comma y. So x is negative 3. I just need to find the y value when x is negative 3. So I would say, okay, f of negative 3 would be negative 3 squared plus 6 times negative 3 plus 9. So f of negative 3 is 9 minus 18 plus 9. So f of negative 3 is 0, right? 9 plus 9 is 18. So f of negative 3 equals 0, which means my vertex is negative 3 comma 0. So I'll put that right there. So now I'll erase that. And once I know my vertex, there are two different ways I can make some other points. So by seeing that a vertex is 0, or negative 3 comma 0, what that tells me is that that is my only route. It's not going to land anywhere else. So I'm going to be struggling to find 2 more points. And this is where you remember your pattern. If that number in front of x, that a value, is 1, then you go over 1 up 1 for your points. So I would just plot over 1 up 1, and there is my parabola. So I can say, okay, I've got enough points to go, and I have my answer. So that is my equation. If I were to factor that to put it in factored form, this would turn into x plus 3, further proving to you that your 0, when you set it equal to 0, is x equals negative 3. That's your 0, which also happens to be your vertex. So that would be when you get something in your standard form, ax squared plus bx plus c. You can easily find the y-intercept. You can easily find your vertex by finding your axis of symmetry, x equals negative b over 2a, and then you plug that x value in to find your y vertex value. This is an example of a function that is in vertex form, so I'll just remind you what vertex form means. Vertex form follows this pattern. F of x equals a times x minus h squared plus k. When it's in this form, your vertex is h comma k. Now the key here is that it is in that minus plus form. So minus 5 plus 2. So in this case, your vertex is 5. It's this number right here, 5. and it's this number right here, 2. So you say, okay, my vertex of this graph is 5, 2. I'm going to keep my axes labeled X and Y, and I'm going to plot my vertex. I'll use a scale of 1 this time. So here's my vertex, 5. Oh, no, I just did that wrong. My vertex is 5, 1, 2, 3, 4, 5, comma 2. Okay, now how do I find some other points here? So there's a couple of different ways. I could find the zeros, and the zeros are actually rather quick to find. So I could say that x minus 5, let's write this again, x minus 5 squared plus 2. Let's just put it in standard form. So to put it in standard form, you practice this in delta math. You would write out x minus 5 times x minus 5 and do your plus 2. So we'll just FOIL this. So you got x squared minus 5x plus 25 plus 2. And now you'll end up with x squared minus 5x plus 27. So that is in standard form. That means that your y-intercept is 0, 27. So it's way up high. So my y-intercept is 0, 27. And I can look at that and I can list my my factors, and I can say, well, okay, I've got 1 and 27 and 3 and 9. So right now I know this is not factorable, which means that it's not going to have zeros. And I can also tell you there's no zeros because I know this is the vertex. That vertex is above the x-axis, and I know that this graph opens up because my A is positive. So again, I have to go to that pattern of if your A is 1, you just go over 1 and up 1, and then over 1 and up 3, and that's how you could get your 5 points. So this would be what that parabola looks like, and you can get the vertex straight from looking at vertex form, and you can get the other points by knowing your pattern. So we're going to review, and our review would be that our vertex form is f of x equals a times x minus h squared plus k. Your vertex is h comma k. The next thing we'll review is standard form. So this is vertex form. Standard form is f of x equals ax squared plus bx plus c. And factored form is when you have it in that factored version. So I'm not going to overload you with memorizing factored form. You just know you take that and you factor it, and that's how you find your zeros. So the zeros are the spots where the parabola crosses the x-axis. So those are zeros, roots, also known as x-intercepts. You know the y-intercept is up here. That's where your x value is 0, and you find your y value. Your axis of symmetry is right through that vertex point, and you find it by doing x equals negative b over 2a. And then you can plug in that x value to find what your y coordinate is. So vertex form and standard form. I'm going to assign you a delta math assignment, and that assignment will give you a chance to practice just a little bit more. One thing we did not talk about was the quadratic formula. So if you are also struggling with that, I'm going to say continue this video, and I'll do that on the next page. The quadratic formula is this: negative b plus or minus b squared minus 4ac all over 2a. You don't have to have it memorized. It is used to find your roots. So it's when your equation is not factorable, it will find your roots for you. So let's go ahead and take an equation. Let's say that we have f of x equals 2x squared plus 3x minus 9. I do not know the answer to this, so I'm getting my calculator ready. So I would say my form is in standard form, ax squared plus bx plus c. And I like to write this down, a equals 2, B equals 3, and C equals -9. Careful with that one. So we'll just plug in. So B is 3, so it would be negative B, or -3. Plus or minus, B squared would be 9, minus 4 times 2 times -9, all over 2A, which is 2 times 2, or 4. So our next step, I'll just slide it over here, is -3 plus or minus 9. 4 times 2 is 8, times 9 is 72. Negative times a negative is positive, so you have 9 plus 72 over 4. So you've got 72 plus 9, which is great. I made up a fantastic problem because I have -3 plus or minus the square root of 81 over 4. The square root of 81 is a perfect square, so this breaks off to -3 plus 9 over 4 and -3 minus 9 over 4. Don't forget these act like parentheses. So you end up with positive 6 over 4, which is 3 over 2, and you end up with -12 over 4, which is -3. So your zeros, your x values, are the x's such that they are -3 and 3/2. These little brackets are called set notation, and this shows that both of those are x's. Don't confuse that with this. That would be your ordered pair. This is not an ordered pair. This is telling you x and x are both solutions. So those are your zeros. If you were to graph this, the points would be, we'll just erase this guy here and say what this kind of more looks like. The points would be -3 and 3/2. You'd have something like this. -3, 3/2 is 1.5, so 1, 2, we'd be right around here. We don't know our vertex, but we could easily find it by doing our -b over 2a. So you could find that and you would say, okay, my b is 3, so -3 over 2a would be 2 times 2 would be 4, -3/4. So my vertex is -3/4, and whatever that y coordinate is. So we could find that y coordinate by plugging in, which I won't do right now because I am really out of space, but my axis of symmetry is here, so I know my vertex is somewhere on that dotted line. I know my parabola faces up because it is a positive a. So again, if you needed to watch this page, I will also be including some quadratic formula problems for you in that assignment. Thanks.